So let me just go through the steps real quick so that you guys know what to do. This is found on page of your lab manual. This is found on page 111, right? First step, number 1, take a beaker of water, fill it up with water, stick your thermometer in there and let it sit for about half an hour, okay? The next thing you want to do is you want to go to a scale. If the scales are all being used, then don't go do that procedures. Do the next one, because we only have so many scales. You guys can go to the graduated cylinders. You can measure your height. You can measure the circumference of this 2-liter bottle. You can go to a different part because you don't have to go do it in order. Okay. The next part is to take a pencil and we already said that. Weigh it. Take a 100 ml beaker. You want to weigh that. You take a 2-liter bottle. You want to weigh that. Between each weighing, you want to tear the scale so that it reads 0. And then finally, you want to take a look at your textbook. Don't weigh your textbook. Okay? What you want to do is, let's say that this is your textbook. You kind of get a feel for it. You know how much these things weigh. You know how much a beaker weighs in terms of grams. You know how much this thing weighs in terms of grams. Estimate the mass of your textbook. Don't weigh it, estimate it. You need to get used to the metric system, and so you want to estimate it. You could probably estimate that maybe your textbook in pounds is about 1.5 pounds, but how much is that in grams? You want to get used to thinking metric system. So you want to estimate it, okay? And then just write an estimate. There's no right or wrong answer, except if you're too precise. If you're going to estimate your textbook as 45.876 grams, then that's too much information, okay? It's an estimate, so you're going to estimate it to like 10 grams or 1 gram. You want to use the best figures to do that estimation. Don't be too precise, because an estimation can't be that precise. The next step is to measure length. That's where we use the ruler. Remember that when you use the ruler, you're going to use the centimeter scale, and it should be read to the 100th of a centimeter. You want to measure your height. The best way to measure your height is just stand against a wall, make a mark, and then take a ruler and measure how high that mark happens to be. Okay, that's the best way. You want to measure your foot. Just take a piece of paper or go to one of these tiles and put your foot in one of the edges, and then mark the end, and then measure your foot that way. Okay, use this ruler. That's the easiest way to measure your foot. And then measure the circumference of this particular 2-liter bottle. You could certainly try and take a ruler and wrap it around. These things are not flexible. The best way to do it is just take a piece of string. That's what the string is for. Cut a piece that is long enough to cut a piece that is long enough to tie, and then all you have to do is mark the sides where they come together, maybe with one of these magic markers, and then measure that length. So that's the easiest way to measure the. Now I have this to begin and this to end. All I have to do is measure that, and that will be the circumference of my 2-liter bottle. That's what the string is for, by the way. Okay. The next step after that is measuring the graduated cylinders. Back there are 2 sets. Make sure you label in your notebook which set you're measuring, the A or the B. These are the A series. They'll say 1A, 2A, and 3A. If you're measuring the B's, then write 1B, 2B, 3B's. But just keep to one set. Don't mix it. You want to measure the volume of this liquid based on the precision that we talked about. Okay? Remember, I'm telling you what precision to use so you won't get mistakes in your lab. Measure the volume of your 25 ml graduated cylinder. Measure the volume of your 10 ml grad cylinder. Then you want to estimate the volume in here. You have an idea of how much this volume is in this cylinder? Estimate that. Does it look like it's 5 milliliters? Does it look like it's 20 milliliters? Estimate it. And again, don't give me an estimate that is too precise. 10.876. That would be incorrect. Probably based on that. Okay, probably not even to the 10. Okay, so you're just going to estimate it. Again, it's to get you guys thinking in the metric system. Okay, when you're done with that, then go to the next page. And this is the last part of this experiment. What you guys are going to be doing is you're going to take one of these cubes. These cubes are either iron, tin, tungsten, what's the other one? Aluminum. Okay, so they're different metals. And what you guys are going to be doing is you're going to be measuring the density of this particular cube. You're going to do it in two ways. One is to measure the density by dimensions, by geometry. What you want to do is measure the height times the width times the length, and if you multiply that against each other, you've got the volume of a cube. Okay? Make sure you use centimeters, because when you use centimeters and you multiply centimeters times centimeters and centimeters, you've got cubic centimeter, which is what? A cc or a milliliter, right? So that'll give you a milliliter of this particular cube. The other way to measure the density of this particular cube is by water displacement. What you want to do is you want to take one of these graduated cylinders, take a note of the calibration of this graduated cylinder, read an initial volume. Then you want to take this, and that's why the string is here. You want to submerge it and read the final volume. The string is not going to be contributing to the volume. The string is very negligible. Okay? So you read the initial, you read the final. The difference is the volume of the cube. Okay? So you measure the density in two ways, by geometry and by water displacement. Before you do any of those volume measurements, you want to make sure that you measure the mass, and the mass for the two methods are going to be the same. Okay? You want to measure the mass first. The mass is going to be the same for both techniques. The only difference between the two techniques is the volume, or the method by which you measure the volume. One is by geometry, the other one is by water displacement. At the end, you're going to have different densities, okay, in terms of the numbers, and you have to explain why these numbers are not exactly the same. And they're not going to be exactly the same. They might be in the same ballpark, 8.7, 8.765, 8.76505, okay? But they're not going to be the same number. And you have to explain why they're not the same. And the reason is based on how you measured out the measurements. Okay? At the end, when you're done with all that, you want to go to the next page, and you see in this worksheet on page 113, you've got a pencil. Write the mass of the pencil in grams there. Write the mass of the beaker in grams there. Write the mass of the 2-liter bottle. And then convert that to milligrams. So you start to do metric conversions in this particular page. For one of these, let's say the pencil, I want to see a calculation that takes you from grams to milligrams, from grams to kilograms, and from grams to pounds. Just the pencil. You don't need to show the others. Okay? But for the others, I want the answers. Okay? For the second part, the length, you want to write down from your data sheet the length of your height, your foot, and the 2-liter bottle. And then for this one, the one that's boxed, 2-liter bottle, I want to see the calculation on the bottom. And then when you're done with that, you go to the volume, and you can see, again, you write down the volume of the 100 ml cylinder, the 25 ml cylinder, and the 10 ml cylinder. And then you convert it to liters, and then you convert it to gallons. And then for your calculation, I just want to see the 100 ml graduated cylinder calculation. Okay? So that's your lab for today. It's mostly measurements with a lot of calculations at the end.